welcome to the project presentation of Team Iris. We're a team of 3 undergraduate engineers, myself Lagonia, Neeraj and Rohan. We started this project, the detection of Parkinson's disease, back in our college days. Let's take a quick look on what Parkinson's disease is. It's a progressive neurodegenerative disorder that primarily affects movement and cognitive senses. It has already affected over 10 million people around the globe, and is noted to have especially occurred in older generations starting from the age of 60. There is no cure for this disease, as well as there is no proper medication for it. Doctors only try to give medications to slow down the symptoms and control the disease as much as possible. Parkinson's disease signs and symptoms comes in different stages, and the Hoehn-Yahr scale is used to measure how Parkinson's symptoms progresses. To give you a small background on how we landed on this project, we noted during our research that Parkinson's come in different stages. The advanced stage, or the stage 4 and 5, is quite apparent, and we can tell that the subject is suffering from Parkinson's disease. Now, in the mid stage or in the moderate stage, doctors usually doubt that the subject may have Parkinson's disease and run a bunch of tests and conclude that the patient is suffering from PD, or the Parkinson's disease. Now, we thought of detecting the disease in stage 1 and 2 when it most likely is to go unnoticed, due to it being the older generation. People around them often assume it's normal for them to have tremor in just one hand, or some sort of facial rigidity, or some sort of balance loss, or something like that. So we wanted to detect the PD in the early stages of 1 and 2. To give a small description on what this project is, Iris aimed to create a software application that works on as an aid to medical professionals in detecting and accurately diagnosing this disease, PD, at early stages. Based on our research, we were able to curate a series of tests, each contributing to a certain score depending on the performance of the individual. Our tests covers various motor symptoms linked with the Parkinson's, such as tremor in arms and leg, rigidity, bradykinesia, which is slow movement, and postural instability, which causes balance problems, as well as mental health diagnosis. We also aim to predict the stage of Parkinson's once detected. So we have incorporated 4 to 5 tests in our software, the first 2 being the spiral and the wave test, the third being detection of muscle rigidity in face, fourth being balance and posture test, and the last one, which is under development, being speech analysis, which will give us an insight of the mental health position of the patient. Each of these tests hold a quantified score, and an amalgamation of these scores will give us a result and let us know what stage the Parkinson is progressing in and if the patient has Parkinson or not. The first and the second test is the spiral and the wave test. So this test helps us detect the tremors in the dominant arm. In a study conducted in 2017, doctors noted that the spiral and the wave pattern, when a subject is asked to draw these 2 patterns, they were able to detect tremors on either of the arms, especially in the dominant arm. So we wanted to automate this system and detect even the minute tremors that occur in stage 1 and 2 using machine learning algorithms. We are using OpenCV, NumPy, and other Python libraries, as well as a random forest classifier, along with image descriptor called the histogram of oriented gradients, or the HOG, to detect the minute changes in the images from a healthy to an unhealthy, or like an affected subject's drawing. We're not using a CNN for this particular test, a CNN being convolution neural network, because our dataset is quite small, over 204 images for both the spiral and the wave test, and CNN may cause data augmentation problems because it does not work well on smaller data sets. Therefore, we're using a random forest classifier. Upon continuous training, we were able to get accuracy of 70 to 75% on both of these tests, and we're looking forward to expand our data set by collecting data by visiting different hospitals and improving on the accuracy of the algorithm. The third test is a face visuality test. We are using a CNN in this, and we are performing a simple task of detecting an emotion of the patient. So once instructed to give a happy smile or a sad smile or any emotion on the face, this CNN algorithm can help in detecting how rigid the facial muscle is and what kind of an expression the patient is making when instructed. Fourth test is the balance test, which will help us detect the stability and the walking speed of the patient. We will have the medical professional instruct the patient to walk a fixed distance, and we will be able to calculate how fast they are moving. And we will also be using axis acceleration using the gyroscopic sensor and see if they're able to keep their balance properly in that fixed distance that they are walking in. Because a mobile phone comes in with inbuilt pedometer and gyroscopic sensor, we have made a small application to collect data of the same. The fifth test, which is under development, is speech analysis. We are using the speech analysis software called Pratt Acoustic Analysis to try and detect the loudness of speech as well as the decibel level, how confidently they are talking. When prompted with different questions, we're trying to detect how their cognitive impairment is with that, as well as we're trying to detect depression from the speech if the medical professional is asking questions related to various parts of their lives and their answers from that. We can also detect different emotions and therefore detect depression as well. Now, this speech analysis can help us give a small insight on their mental health, so that can also be kept track of. Now we will move on to a small demo of the project.
The first test will be the spiral test, followed by the wave test, followed by the face rigidity test, and the last balance test. So the way we have planned to conduct all this test is that the instructor will be uploading a spiral drawn by the patient. Our machine, with the help of its OpenCV machine learning code, will detect whether the spiral has any indication of the patient having symptoms of Parkinson's disease. So once the instructor uploads the image of the spiral drawn, uh, our machine will detect whether the person is healthy or has any signs of the Parkinson's disease. Here's a sample output for when the patient is healthy, output for when the patient is showing signs of Parkinson. Similarly, for the wave test, the patient will be asked to draw a wave pattern and the instructor will be uploading that particular image. Here's a sample example of a waveform drawn by a healthy person and detected by our machine. Here's an example of a waveform drawn by a patient affected by the disease and as detected by our machine. Moving on to the second test, first two being the drawing test. Face rigidity test. So in this, the instructor will have to let their system camera detect the patient's face as well as any change in the facial muscle rigidity. Once the instructor gives software the permission to use the system camera, the system will detect the person's face or the patient's face and check for any signs of rigidity in their facial muscles once the patient is asked to smile. Here, since I am a healthy person, when I smile, it detects so and says as such. As and when the facial rigidity test is done, the next will be the balance test.
The last test is the balance and posture test. Due to the disease and the rigidity of muscles in the patient's legs, they start losing balance and their pace reduces. So we developed a mobile app to calculate the number of steps taken and the speed of the patient to cover a certain distance. We also measure the acceleration in the x and y axis to determine the stability of the patient while they are walking. We have measured the above mentioned properties using the pedometer and gyroscopic sensors built in the mobile phone. This application is as follows. So while uh, walking, the steps get counted. Here is the result of a positive, a healthy person.
Moving on to the application and advantages of this project, we are all aware that the current diagnostic procedures include a lot of neurological and physical examinations, which is necessary, but it's also followed by highly expensive CT scans and MRI scans. These are only done in like the third stage and are usually used multiple times to make it as a process of elimination and eliminate other possible neurodegenerative diseases that are not Parkinson's disease. So our software helps the medical professionals to corner it to PD, as well as it helps in faster recognition of the disease. It is also economically friendly for the subject or the patient, and reduces cost of diagnosis and is also easily accessible. Our software can be implemented on baseline diagnosis in primary healthcare centers, in villages and rural areas, as well as in old age homes and NGOs in the urban areas. To conclude, our team is highly encouraged by many assuring engineers as well as judges from many different competitions to complete this project with a complete database and a stack and a complete functional format, as well as we are also looking forward to go and physically collect data from different hospitals, which we have been visiting government hospitals to collect data, and we're also like looking into any other NGOs or old age homes that will be willing to give us data as well. We're also extensively researching on speech analysis part of the project, since it's a completely different chapter. We're also parallelly working on that particular project and trying to incorporate detection of depression from speech in this project as well. We're also trying to look for a proper scaling system that will help us, along with the existing Hoan and Yar scale, to depict how much the disease is progressing. We're not necessarily looking into commercializing our project because we're doing it as a part of our own will, and we wanted to provide it to and make it easily accessible by everybody, especially the medical healthcare administrators in the government side or in the non-profiting non-government organization as well. But we will be looking into different aspects of monetizing some parts of the test. For example, the speech analysis part can be monetized if advertised properly to other firms as well. So we are looking into that as of now. Thank you.